Hello, co-champs, number ninjas, and daring data divers. Today, I'm chatting with Daniel Slutsky. Daniel's a mathematician and a community organizer at SciCloj. He earned his master's in mathematics, doing a thesis on quantum probability, and is a software engineer. He spent a lot of his time building localized real estate portals and has created several important data science libraries, including Clay, Kindly, and Nodge. I got to know Daniel through many discussions about literate programming and data visualization. Welcome, Daniel. So I've been seeing a lot of exciting notebooks being created recently by Clay, and I enjoy using it a lot. Can you tell us a little bit about what your inspiration was for creating Clay and what it does?
Clay is a Clojure way to take a Clojure namespace, or just maybe one Clojure form or one Clojure value, and turn it into a page. A page could be a notebook representing that namespace, or just a data visualization of this one form or one value, or it could be a slideshow or a book or a few other things. I think Clay is a simplification of a few other ideas we've had in the last few years, which were uh, never complete and never got to be completed. And the realization was that we could do something which is just less clever and will be just complete enough to be used. And that is Clay.
Can you tell me a bit about quantum probability? I don't know what that is, so I'd like to hear about it.
Probability theory is the way I'm used to think about data and about situations in an abstract way. It was phrased in the early 1930s by Kolmogorov as a set of axioms, the axioms of probability, statements about sets, which we call events, and the probabilities of those events. Sometimes it is valuable to look into our axioms and ask, could we change something? Could we assume a little less? Familiar example is geometry, where many of us are kind of used to the Euclidean geometry, which is
Mm.
based on a set of axioms by Euclid. And sometimes it makes sense to drop one of axioms and sometimes replace it with another and get another geometry which is useful in another way.
In Einstein's relativity, his modeling of space-time basically took the Euclidean geometry and extended it to space-time. Riemann did the math, but Einstein took advantage of it to basically, instead of like looking at Euclidean geometry, you just try and fit the geometry of gravity. Euclidean geometry is on a flat plane,
Yeah.
and Riemann theorized, well, you could do it on a sphere,
Yeah.
and so just how do you change the rules um, so that things work? So some things that change is like on a flat plane, two parallel lines will never meet. But on a curved surface, two parallel lines will always meet. In many ways, space-time is similar because objects that are apart tend to fall into each other over
Oh,
time. So if you imagine time being moving from the equator to the North Pole, that's very similar to gravity.
yes. Yeah. So we dropped the axiom about parallel lines never meeting each other. And and yeah, and in probability, one may do something similar. But before doing that, one needs to rephrase probability in a different way, no longer about events, which are just abstract sets, and the probability of those events, but rather around random variables and the expectations of these random variables. So random variables are basically functions. They are functions from the abstract sample space to numbers, saying, yeah, you know, my the random temperature today in my town, what would it be? So that's a random thing, and then it is a function to the space of temperatures, like numbers, basically. So random variables are the central objects of a different way to phrase what probability theory is, which is equivalent to the Kolmogorov set of axioms with sets. But then when you work with random variables, you can drop one assumption and replace it with other stuff and get other kinds of probabilities. It is like a common process in math where you switch from focusing on sets to focusing on functions over those sets. Random variables, to recap, are functions over our sample space. The sample space is the space of all possibilities in the world, or maybe a more limited space of all the population of a very kind of finite population we care about, but very often it is like an infinite abstract space of possibilities, and random variables are functions from each of these possibilities to the actual value they would take if that possibility would take place, like the actual temperature in that scenario. So random variables can be defined as many functions over the same space, and then you can talk about the relationships and also about the expectations, like what is the expected temperature, and then what happens when you multiply two random variables. One of them might be the number of tomatoes I ate today, and the other one was the number of calories per tomato. When you multiply these two random variables, it doesn't matter if you multiply the first one by the second or the second by the first, of course, because it is basically multiplying functions that take us to numbers, and numbers can be commutative, as they say, right? You can replace numbers when you multiply. It's a commutative operation between them. And we may drop that. We may talk about a similar setup where they do not commute. You cannot replace them while multiplying. And that is kind of strange. To think about that, we need to drop whatever we had in mind, we actually imagined the original probability theory. But in a different setup, it may make sense. And yeah, and we are used to other operations between elements that are not commutative, where you cannot replace the order, like composition. Like when you compose functions, you compose one function on top of the other and then replace the order, it will not be the same, right? So we may imagine an abstract situation where we have the things we still call random variables, but they do not commute. You cannot replace them. And then you can add other assumptions about what happens when you compute expectations of certain multiplications and how all these things operate. And basically, quantum probability is this situation where we forget about commutativity and possibly add other assumptions that will result in different flavors of quantum probability. One of them will be useful for quantum mechanics. Another one will be useful for the probability theory of random matrices. And another one will be useful for something called group representation theory, for those who care about it. And those different fields may have some things in common. We may learn from one of these non-commutative probability theories and use what we learn for another one. And in a way, it is a generalization of probability theory, but also a concrete set of other examples, like dropping the axiom of parallel lines was a way to generalize geometry, but also propose other geometries which are concrete in a different set of axioms. And then it can be used for different uses. And my studies in math were about that.
I always chuckle a little bit how mathematicians like yourself, you always call things random variables, but it feels like to me a lot of things aren't completely random. Like, you know, if you choose any, I guess you're talking about tomato sizes. Like, it's not random because like someone watered the tomato the right amount to make it grow big.
There is some uncertainty about it, but some things can be estimated or predicted more or less reasonably, right? So one, specific case of that is that where one is really certain, where, there is not so much of the uncertainty. And yeah, we probability theory people would just consider that a special case. The case where there is not much uncertainty is just a special case of the diversity of cases where we can have more or less uncertainty.
A while back when we were chatting, actually we had to stop every hour so that you could go to a bunker and avoid incoming rockets. I, I, so I guess I just want to ask generally, like, what's your life like in Tel Aviv right now, and what are the impacts of the war that's going on?
Yeah, thank you for asking. So, yeah, I live in a town nearby Tel Aviv, and here it is Tel Aviv at the office, and I'm an Israeli citizen, so I'm part of this um, troubled situation. And inside this situation, first, I'm kind of privileged to be relatively safe at the moment. Here at the center of the country, we only hear the war from far away. And of course, it matters to us and we are concerned. As citizens, we are kind of responsible for what our country does. And, and even if at the moment it feels we are rather powerless with the current situation, we should see what we need to do, where uh, the whole country and the current government and other parts of the state are becoming really criminal and in what they do. And I think that's the current situation where Israel is acting criminally to the inside and to the outside. And the people are mostly hurt by that are, of course, the people in Gaza. And that's horrible, really horrible, more than we can imagine. And we are really wondering here what we should do with not much of good answers for now, internally here in the country. And internally, this criminal violent situation takes its own shapes, which are possibly a bit less dramatic, but still they affect us. And I think mostly we are learning what it means to be in a society which is kind of breaking apart, but also in this integration also get some forms of solidarity and protest and struggle, as well as hatred and fear and trauma and pain. And we are learning about all of that in a new kind of mix that we never got to know this way. For many of us, our attention to the local stuff is becoming more serious and more aware, hopefully, for now, without any solution.
It seems like there's no possibility for peace. Like, do you see a way for peace to happen?
At the moment, it looks really far away because we realize how much of the last 9 months was about violence and pain, and realizing what some people had to go through and what the society went through, and the way all of that, in all the many different groups which are here, all of that was translated mostly into fear and hatred. It looks like there is no easy, quick path to actual peace. Something will remain of this pain for quite some time. Kind of question we should ask is not just about politics. where we try to do something, it is also about pain, which is like kind of central to the situation. People are looking for ways to take care of each other. Politics is not enough.
For as long as I've known you, you've been interested in communities and building communities, and especially SciCloj. Can you tell us a little bit about what SciCloj is?
SciCloj is a loose group of people who care about using Clojure for data and science, different situations where one has some data to explore or analyze or process or present in a way which is more or less scientific. Some of the people in this SciCloj group have been involved in creating open source solutions and actually continuing what they have been doing years before SciCloj existed. And some of the people involved are more about teaching and learning and helping each other and creating this space as a social space.
What sort of people participate in the community?
Some of what we do is goes around what we call study groups. A few of us meet occasionally, once a couple of weeks for a year, and study a certain piece of technology or practice something together or build a library together or read a book together. A lot of that is not so visible. Some of these meetings are just one-on-one meetings, two people we may not even know who meets once a week. Or yes, sometimes a talk can be recorded and published in a very polished and careful way that is kind of that can be used later as a learning resource. But a lot of what we do is just a draft. It's just like an intermediate step on the way to something that may get complete later. And we want it to feel safe for all of us to be in the process and to be confused and do mistakes. And what we're trying to do is to create the spaces where it is just convenient enough to be as confused as we need to be. And then alongside these, we also have the chats where we, work and collaborate offline. Some of the people who have been most active in the open source side in creating libraries are actually more active in the chat more than in the meetings.
What's so important about SciCloj in particular as a community to support?
I think for a few of us, we have reached Clojure on the search for something like that, for the kind of experience where we can actually feel comfortable doing what we do. And the social aspect of it is part of this story. Being convenient, doing what we do, relies on having colleagues and friends to collaborate with and to study together with. Creating this situation is a long process. It is not complete yet. It is also a very technical process because some of what we need doesn't exist yet. I think part of what we realized is that specifically for a data science community, it matters not only to have a great stack of libraries, which we are gradually getting, but also to have this kind of social support and popularity where actually a great bunch of people use the tools for a diversity of use cases. And without that, a good stack of data libraries cannot be sustainable. You need the diversity of data problems and opinions and flavors and preferences to let this thing grow healthily.
When I look at SciCloj, I see so many libraries. It's a bit intimidating. I'm not sure like where to start. I think on the library list, there's literally hundreds of them. Tell us about one that stands out as maybe a good place to start first.
I think Encanter was a great inspiration. I was brought through this rumor about this kind of thing existing and a friend telling me I should look and learn about it. I think one thing Encanter had is that it felt like one thing that had this kind of harmony about it, handling different kinds of needs, processing, visualization, analysis, but in a way that was well documented and well presented as one library. And now, where we have a little more of everything, we don't have that yet. And then coming to the question you proposed, what would be one library to look at? The answer we are trying to create these days is the library we call Nodge. Nodge is trying to be an opinionated collection of relevant Clojure libraries for data and science. Not all of them, but like a recommended choice of a few of them that are known to work well together, documented together, integrated together. Nodge is like short for Cynosure, and Cynosure is metaphorically like a clear direction of where one may look, the North Star, as they call it.
It's clever. I didn't know that's what it meant. To play the devil's advocate a little bit, the
Yeah.
problem with Nodge, as I see it, is I still have to go and figure out what those things are. So maybe we can talk about the key projects that Nodge combines.
And yeah, so let's mention a few of them. One of the libraries worth mentioning is Fastmath by GenerateMe, is this very diverse and huge collection of math and statistics functions, data transforms and statistical functions and randomness and probability distributions and signal processing and some matrix computation a little bit for small cases and many others and numerical algorithms, optimization and so on. A lot of it has beautiful documentation. Quite often the answers to one's needs will be there. And then there is data processing where one may look into Tablecloth.
Just one thing on Fastmath that I'd like to add, besides doing lots of things, it also does some basic things really well. The mode, the percentiles, linear regressions.
And I think that's the point for all of us, that we just need those basic things collected, and that is one place to find them. And then there is Tablecloth, which is about data processing as columnar tables. And that is something that people may know is common in other data science cultures. Python, they have pandas, and in R, it is the basic data frame. And in Tablecloth, it is called a data set. Columns may have types and are stored in a compact way that is efficient for time and space. And also a lot of the ergonomics of data processing are organized by processing whole columns. Like you define a new column as a combination of existing columns by some function. Some people may also like to work with rows. Many relational databases are organized in a row-wise way, and many APIs of data processing are organized in rows, as in Clojure, many people like to do, working with sequences of maps, which are conceptually rows in a dataset. Tablecloth offers a way to take a columnar dataset with all the efficiency it has and handle that in a row-wise way through a clever view that doesn't copy the data with no data duplication. And that is kind of special and exciting and brings beautiful ideas of ergonomics, which are uncommon in other data frame libraries in other languages as far as we know. Behind it, we have TechML dataset, this high performance library. Tablecloth is mostly by our friend GenerateMe, and TechML dataset and dtype next, and a few other related libraries are mostly by Chris Nürnberger and our friends in TechAscent.
What I didn't realize until I started using it was how nicely it prints tables at the REPL and also in notebooks. I quite like using Tablecloth just for any table that I want to look at because it's so much nicer than the inbuilt table printers. And it has some smarts to it, like it aligns the columns correctly for numeric data, things like that.
For many Clojure people, the initial reaction would be, why would I need any of that? I know I can handle sequences of maps and it is just fine. Why do I need those columnar table structures? And the point is that performance is part of the answer, but ergonomics is a major part of the answer as well. Yeah, they put so much care into the little details, like printing numbers in a way which is aligned nicely. One other library, which is not a SciCloj project, but it is by a friend of us, Dragan Juric, is Neanderthal. And Neanderthal is about processing matrices of numbers. Neanderthal offers more of the numerical algorithms and linear algebra algorithms one may do with matrices. Neanderthal is taught through Dragan's blog and through books, is a lot about learning this practice of controlling memory and being careful about when we actually mutate, because that's the efficient thing to do. And it is, for many Clojure people, it is a different practice from our common habit, and it is valuable for certain scenarios. These days we're having great tutorials about Neanderthal by our friend John Anthony, who is an experienced mathematician and numerical algorithms person and many other things, and has been doing a few really enlightening sessions in our study groups about Neanderthal. Machine learning is a certain discipline by which we teach machines functions, basically. Some of them are unknown to us, things that are conceptual functions that happen in the nature, like how would I predict the number of calories in this tomato? We teach the machine to predict the value of the function by showing it some data. But to do that, we need to use some algorithms like decision trees or forests for those algorithms where one have many trees combined, and also deep neural networks and so on. There is a library called MetamorphML by Carsten Behring. Metamorph itself, a very simple notion of a data pipeline, which is similar but different from the usual Clojure notion of a middleware. MetamorphML is Metamorph with lots of processes and ergonomics for machine learning specific pipelines. And so we would recommend using MetamorphML with the TreeViewer collection of Java algorithms where it matters. And then there are other choices when one actually needs to go about deep neural networks. So for deep neural networks, which are those heavier machine learning models, there is a wrapper for the deep Java library, and there is this pure Clojure library called Deep Diamond, which is built on top of Neanderthal that we mentioned earlier. And so we have a nice growing collection of machine learning algorithms we can use in Clojure. What it is still lacking is the depth of the ecosystem that only Python has. Deep network architectures, which are built in many, many diverse ways, and also pre-trained in many diverse ways. And this huge ecosystem exists only in Python nowadays. That is one of the reasons we need good interop. Clojure has grown with the respect to different hosting environments where it may live, like the JVM and the CLR and the browser and different flavors of JavaScript. And the culture of Clojure people naturally expects it may integrate well with other runtimes. Sometimes it is not by implementing Clojure on top of that runtime, but rather by connecting to it as a separate process or in an in-process method, so that we can call function of another language. And also not only call functions, but sometimes do more elaborate stuff in a zero copy fashion, as they call it, where you have a data structure on the other side and you may apply a Clojure function to the thing you have on the other side. And some of these things are possible in Clojure. So languages like Python and Julia, which matters a lot for science, and R for statistical computing, and Wolfram language for math and many scientific uses. All of them have really great solutions for interop within Clojure. And this brings lots of interesting questions about Lisp and expressions and the way we express a certain situation where some of your process lives on this runtime and some of it on the other, and you wish to express it in a nice Lispy way.
You haven't talked about Clay yet, which is one that I actually think is really interesting and has applications outside of data science as well. I personally use it all the time and like it. Maybe you can tell us a bit about that side of things.
One thing we skipped is data visualization,
Mm.
where the library that creates a visualization of a given data set or data situation. And yeah, and the other thing is visual tooling, as some of us call it, where the goal is sometimes, performing data visualization, like sending something to be visualized in your browser, and sometimes a more elaborate situation like creating a notebook in this literate programming fashion. First, to talk about data visualization, or the task of taking some data set and some declarative description of what way you would like to visualize it.
Why is it important to visualize data at all? And what
Yeah.
sort of visualizations help us?
Very often, the point is that a picture can be a way to intuitively see some phenomenon. We can use visualization as a way to communicate some findings about our data in a way that will be clear to our audience. It also means that we can use it as a way of analysis. I may have a question about the data. Very often, the quick way to answer it might be to look into a certain plot, like a scatter plot, visual summary, like a histogram or a density plot that gives me an idea of what there is there. First and foremost, data visualization is a tool of analysis. Some of the ideas of data visualization is to see the common parts between different ways of plotting and actually represent them in a way which is reusing the principles and just varying a little thing like coordinate system. Is it a geographical plot or just a plot over the Euclidean plane that we use? There are things which are very different, right? Like plotting networks, like a graph with nodes and edges, which is a completely different thing. And then again, we often use the plane, but we represent something that doesn't necessarily have clear coordinates, but more of the relationships of what is or isn't connected and what other things may have in a network.
I don't know, maybe this is too strong a statement, but I feel like actually like visualizations are the only way that we can truly understand numbers.
That's nice. I like that we can say brave things like that. And I think realistically, yeah, that's what we do. When we explore, we actually often just do a plot. Very often we would use many JavaScript libraries that offer a certain way to specify a data visualization in the browser. And many of them are declarative, using some JSON specification. So it is very convenient to generate whatever they need from the Clojure side and send that to the browser.
The thing that works best for me personally is to focus on producing a Vega Lite spec and use Clay to show it.
Clay is a way to create pages out of Clojure situations, basically. You may have a Clojure namespace or a set of namespace, or maybe just one value or one Clojure form, and you may need a visual representation of them. One may imagine different ways to do it, like you can take one Clojure value or form and turn that into a visual representation, like a plot in the browser. Or you may have a whole namespace and generate a whole notebook full of the code and comments and visual representations of all outputs. Or you may have a set of namespaces and create a book out of them. Or you may have one namespace and create a slideshow out of it. These are quite a few related situations where in all of them, what we do is create basically HTML or more generally pages in some representation out of Clojure. Some of us like to call this habit namespace as a notebook, because namespace is the main object very often and notebook is often the thing we're creating. Out of a few namespace as a notebook tools, it tries to be the least clever one. It tries to do the least needed so that it would not interfere so much with the usual way people use the editor and the REPL, and sometimes may need to visualize something.
Tell us a bit more about the visualization story of SciCloj.
One of the favorite ones is Vega Lite, and there is also Vega and eCharts and Plotly. And it is worth mentioning all of these because in certain scenarios, one can be preferred over the other. Some of us at SciCloj tend to prefer Vega Lite, which is one flavor of this grammar of graphics culture that for those who care about it. And Vega Lite quite often is an easy answer, an easy and simple answer for creating a plot. And yeah, so that is one recommendation for anybody who wishes to visualize something. Just use Vega Lite, which is so easy from Clojure. And then there are certain Clojure libraries that allow to generate Vega Lite plots in a less verbose way, in an even less verbose way, because Vega Lite is not so verbose. Two of them worth mentioning is the famous Hanami and the additional Hanami cloth. One more thing worth knowing about, that is CLJ plot. And CLJ plot is a pure Clojure library for creating plots. And it is really detailed and so well documented with many examples.
And how does Kindly fit in?
Kindly is a way to request data visualizations. The idea is that Clojure data structures can be representations of data visualizations, like, a simple Clojure map, like a nested map with the relevant keys, can be interpreted as a Vega Lite plot. This needs to be annotated in a standard way so that different Clojure tools will know, oh, this should be considered as a Vega Lite specification. And what Kindly does is offering this kind of annotation, annotating our values, sometimes explicitly and sometimes automatically, so that relevant tools like Clay and other tools will just know how things should be visualized.
What's the best way for people to get involved?
SciCloj is relevant to any Clojure person who may have some data to explore or to analyze or to process. It is not just like a certain people of a certain discipline, like statisticians and so on. It is just about data. And so hopefully what we do can be relevant to almost any Clojure person and to any person with data at all. Like, are you a geographer or a biology person or a social science person or just somebody who may have run into some data about their life and their story? SciCloj is trying to be relevant for all these people. Getting involved means sometimes studying together, practicing together our uses, our needs with data in a way that can be shared. Of course, not everything can be shared, but we try to find ways to collaborate in a way that is relevant to people's needs and interests, people bringing their own data and problems and interests. And then there is also the open source side, where we create documentation and tutorials and books and libraries and tools. And there are actually lots of opportunities to get involved and create something which is relevant and will be used by others. And if you are a Clojure person who, may know like something about Clojure and wish to get involved in open source, I think SciCloj offers lots of opportunities like that.
One thing that's very frustrating for me in the Clojure community is that I have to be on Slack and on Reddit and Clojureverse and Ask Clojure and Google Groups and Zulip and Reddit and Stack Overflow. There's just so many communication channels that it feels a bit overwhelming. Where should I participate? Which I understand the reasons for that. In SciCloj, is there a preferred way to contact each other?
There are all those platforms, and we try to embrace that. We recognize that some people tend to hang out in certain spaces, and we will be there where it is relevant. I think the Zulip chat has been most useful and really, really productive as a way to build a community and create a space and aggregate knowledge and organize knowledge in a way that is kind of organic to the way we work. So knowledge emerges as our topic threads of conversation. And I would recommend Zulip to anybody who tries to create this kind of community. And I would recommend anybody who wishes to get involved in SciCloj specifically to join the Zulip chat and reach out there. But you may find us in many of the other platforms as well.
Oh, that's great. There's also a calendar. It's actually the Clojure calendar, but a lot of your events appear on that calendar.
Gert has created a calendar feed where Clojure events can be announced in a very easy way with a nice API. and can also be consumed in very diverse ways for different needs. Most of our public events at SciCloj are available on the Clojure calendar feed. And I encourage anybody to join this calendar and watch it in the different ways one may watch it.
Actually, I just recently discovered that I can add it to my Google Calendar. I wasn't aware that I could do that before.
Yeah, and also it is an opportunity to say thank you to our friend Gert, who has created the Clojure calendar feed, as well as the the transparent and wise moderation of the Zulip chat. Gert has been behind the scenes in a few of the things we are really thankful for.
Is there a mentor in your life that's been an inspiration to you?
Even today, as a grown up, it is my core family who is influencing me the most. So yeah, we used to be four, my mother and father and brother, and now father is not alive anymore, and so we are three. And I used to consider this as one person in a way. That is something that my brother taught me, that even though these four people used to be very different from each other, there is something in common, and the influence and the way they teach me and what I'm getting from them is like getting from one person in a way, or one spirit of a person. They have their eyes open, so they actually look into the world in a sincere way, this kind of seriousness in a way, which is sincere and actually trying to see what things are about, but also with humor, not like taking themselves too seriously. So it is this kind of combination that I hope I can learn more.
What's the best piece of advice you've ever received?
My father used to tell me, like when I was a teenager, which is really many years ago, that I would rather get involved in like social movements, and then this kind of advice from a parent may take me decades to embrace, and my father used to have this kind of patience, knowing I may be slow in learning and actually realizing something, and sometimes it may not happen, sometimes it may happen a couple of decades later. And yeah, and I think eventually, as somebody who was more of an introvert, sometimes working more of like alone, I have eventually learned to keep being introvert, but in a social way, hopefully. So I that was a good advice by my father a few decades ago.
Have you made any mistakes in your career and maybe learned something from them?
It would have been wise to let go of those hopes and actually do something simple, which is good enough. Having this kind of inertia where I'm having these big hopes and ideas I stick with, and I hope I'd learn to listen and look at the current situation and ask, should I be doing that? Is it necessary to be able to let go and actually focus? And that's sometimes the path to simplicity, isn't it? Being able to focus on a clear idea of what we actually need. Even though I know sometimes simplicity is also about generalizing, removing unnecessary stuff, but also generalizing, like finding the common general idea that will allow things to be more to be simpler.
I have some nieces and nephews, and it feels like as they're growing older, there's so many choices now in terms of careers and how they should live their life. It's so much more complicated than when I was growing up. And I was wondering if you have some advice that you would give to someone who's be considering data science as a career, how to get started and what things to focus on.
That is probability theory. That's not obvious. And I think, it is my opinion because that's the way I learn things. It is a certain way to think about data and data situations. Those axioms of probability and the structures one may build on top of them, they offer a way to make these things principled, to reason about your data and data situations, principles that may be a nice guide when one has like a dilemma. And the continuation of using probability reasoning is this practice that is called Bayesian statistics, which is actually like Clojure, simple and friendly, but needs like an open mind. And I think it is worth it. I think getting some principles is worth it. And please know, it is not like the highest mountain to climb. Actually, it is not such a long way to learn probability and make it your friend.
Anything you want to add?
To our listeners, I think we need you. Please reach out. What we're creating needs the Clojure people, and probably it is more relevant to your needs than you imagine. So please reach out, let us talk.
A really great way to conclude.